Before the story starts, let's take a few minutes to let the body go. Find a position you can stay in comfortably, lying down if you can. Let your arms rest at your sides, and let your legs be uncrossed. When you're ready, let your eyes close. There is nothing to achieve here, and nothing to get right. Take one slow breath in, through the nose. And let it go, all the way out. Again, breathing in. And out, a little slower than the breath in. Once more, in your own time. Now let the breath go back to its own rhythm. You don't need to manage it. Bring your attention down to your feet. Notice whatever is there: warmth, weight, the press of the blanket. And let the feet soften. Let that softening move up through your ankles and your calves. Let your knees be heavy. And your thighs, all the way up to your hips. Let your hips settle down into whatever is holding you. Bring your attention to your belly and let it be loose. Let your lower back release into the bed. Let your chest be easy. The breath moves on its own. Let your shoulders drop, away from your ears. Let your upper arms go heavy, and your elbows. Let your forearms, your hands, and each of your fingers go completely loose. Let your neck lengthen, and let your throat soften. Unclench your jaw, let your teeth come apart a little. Let your tongue rest, and your lips. Soften the small muscles around your eyes. Let your forehead be smooth. And let your scalp release. Now feel the whole body at once. heavy and warm and still. Nothing needs doing, nothing needs deciding. In a moment, a voice is going to tell you a long story about a stone, and the sea, and the light in the sky. You don't need to follow it. You don't need to remember any of it. Let it go by like weather. Let your body stay exactly as heavy as it is now. And whenever sleep comes, let it come. The stone that hides itself. About 900 meters north of the lighthouse on Alderney, the northernmost of the Channel Islands, a local fisherman snagged his gear on something in 1977, in roughly 30 meters of cold green water. The obstruction was a small English warship of the late 16th century. Broken and half buried in the sand of the channel between the island and the coast of Normandy. Oak from one of the covers over its gun ports was felled after 1575. Lead weights for a balance came up stamped with the monogram of Elizabeth I. Muskets came up locked inside lumps of concretion, the hard crust that grows around iron left on a seabed. Iron guns lay on the bottom nearby. Divers worked the site at intervals through the 1990s and after, lifting thousands of objects from it. One of them was a lump of calcite, the crystal form of the mineral that makes limestone, roughly the size of a small bar of soap, its edges trimmed at an angle, its faces gone milky white. Chemical analysis identified it as Iceland spar, the transparent form of calcite that splits a beam of light into two. 400 years of seawater had abraded it with sand and clouded it with magnesium salts, so it can no longer split anything. It was lying less than a meter from a pair of brass navigational dividers. The ship went down around 1592. The Viking Age was over by about the year 1100, and this crystal has been described in headlines as a Viking sunstone ever since 2013. At the center of all this is an Old Norse word, Solarsteinn, sunstone, from the language of medieval Iceland and Norway. It appears a handful of times in medieval Icelandic writing. Exactly one passage shows anybody using such a thing. That passage sits inside a short narrative called Hrothulf's Daughter, the tale of Hrothulfr, which survives as an insertion into the longer life of King Olaf II of Norway, the king who became Saint Olaf. 9 medieval manuscripts preserve it, the earliest of them from around 1300. Scholars generally place the composition in the late 12th or 13th century, before the Icelandic historian Snorri Sturluson wrote his own shorter version. Since Snorri's chapter reads as a compression of this one rather than the other way about. Its author is unknown and was probably a churchman. Olaf is a guest at the farm of a man named Hrothulfr, who has 2 sons, both of them uncanny. The weather that morning is thick with falling snow. Olaf sends someone outside to look, and there is no clear patch of sky anywhere. He then asks one of the sons to say where the sun has got to. The boy gives a precise answer. And then the king has the sun's stone brought and held up, sees where the light comes out of it, and finds that the stone agrees exactly with what the boy said. Nobody in the scene is at sea. A king in a farmhouse is checking whether a boy's gift for reading the sky is real. And the stone is the king's instrument of verification. All of it happens the morning after Olaf has dreamed about the house he slept in, a house built as a model of the created universe, with a ceiling running from God at the top down to the creatures of the sea at the bottom. The remaining appearances are thinner. A Solarsteinn turns up in one other saga, inside a sequence of allegorical visions that foretell the death of its hero. And that same passage was copied into all 4 medieval versions of the life of Bishop Guðmundur. Beyond the narratives, sunstones appear in a small number of late medieval Icelandic church and monastery inventories, listed among the possessions of those houses without a syllable about what the stones were for. That comes to 2 narrative sources in all, plus a few inventory lines, and none of them names a mineral. In 1967, Thorkild Ramskou, a Danish archaeologist, published a short piece about the saga stone in the Danish popular archaeology magazine Skalk. Among its readers was the 10-year-old son of a chief navigator for Scandinavian Airlines, who told his father that the thing described in the magazine sounded a great deal like the instrument his father used at work. What his father used at work was a twilight compass, also called a sky compass. Aircraft flying polar routes in the 1950s and 60s had a real problem. Near the magnetic pole, a magnetic compass is close to useless. And on a high-latitude flight, the sun is often just below the horizon for hours. So an instrument that works from the sun's shadow has nothing to work with. The twilight compass was built for exactly that gap. It carried a polarizing filter, and it read the polarization of the twilight sky. Light waves up there vibrate in one preferred direction, and the filter finds that direction, pointed at the sky directly overhead and turned until the view darkened. The instrument gave the bearing of a sun nobody could see, meaning its direction round the horizon. Ramskou took the resemblance seriously. He tested cordierite, a crystal that occurs naturally in Scandinavia and changes color sharply depending on how it is held against polarized light. Then he went up on a flight to Greenland with the navigator himself, keeping track of the sun with a stone in his hand while the navigator worked the twilight compass, and a fuller book followed in 1969. Physics, at least, is not in doubt. Sunlight scattering off air molecules comes out polarized, which is to say the light waves end up vibrating in one preferred direction rather than every direction at once. And the geometry of it is clean. Picture the sun yourself and one patch of sky overhead. The light coming from that patch is polarized at right angles to the flat sheet those 3 points sit in. And how strongly it is polarized depends on the angle between the patch and the sun. Sky right beside the sun is barely polarized at all, and so is sky directly opposite it. 90 degrees away from the sun, polarization reaches its maximum. So on any clear day, there is a great band of strongly polarized sky overhead. A ring drawn a quarter turn away from the sun, wrapping the whole dome from horizon to horizon and moving with the sun as it goes. The light in that band can be 70 or 80% polarized. Nobody knew it was there until the 19th century, and bees and desert ants had been reading it the whole time. In a real atmosphere, the pattern is not quite the clean one the geometry predicts. There are 3 points where the polarization falls to nothing, and they sit near the sun and near the point of sky opposite the sun rather than exactly on them, and they shift as the sun climbs and falls. And the pattern does not switch off when the sun goes down. With the sun below the horizon, the band of maximum polarization sweeps up across the visible sky. So twilight offers a strong, wide, well-defined signal. Reading the pattern requires something that responds to the direction of polarization. Calcite responds by splitting. It is birefringent. It bends light by 2 different amounts at once. A ray entering the crystal comes out as 2 rays, an ordinary one and an extraordinary one, whose bending depends on which way the crystal is facing. Look through a block of Iceland spar and everything doubles. Because the 2 images are built from light polarized at right angles to each other, their relative brightness changes as the crystal is turned. Rotate until the 2 images look equally bright, and the crystal has found the direction of polarization in that patch of sky. And therefore, since the strongest polarization always lies a quarter turn away from the sun, roughly where the sun is. Matching 2 brightnesses against one another is what physicists call a null measurement, where the reading comes from finding a balance rather than from a number on a scale. Guy Raupars and Albert Laflauc, physicists at Rennes, push the idea further. Rather than compare 2 large image fields by eye, they used a small aperture and set the 2 beams directly against one another, working at what they called the isotropy point. The crystal orientation at which the 2 beams have strictly equal intensity, and the emerging light is fully depolarized. Their published claim is a precision of about 1 degree in the sun's bearing round the horizon, falling to a few degrees in deep twilight. Cordierite and tourmaline work differently. They are dichroic rather than birefringent. Instead of splitting light, they absorb it selectively depending on its polarization. So a single crystal turned in the hand changes color or darkens. Cordierite in particular swings from a deep blue to a pale yellowish gray as it turns. The gem trade sells it under the name Viking's compass. One version of the technique requires no crystal at all. Polarized light produces a faint response inside the human eye itself, a yellowish bow tie shape called Heydinger's brush, after the Austrian physicist who described it in 1844. Arising from the way pigment molecules are arranged in the central patch of the retina. It covers only 3 to 5 degrees of the visual field, faint and intermittent. Some people find it easily against a blue sky 90 degrees from the sun. A good many never see it at all, and most people have to be told the thing exists before anything appears. A laboratory in Budapest has spent about 20 years testing the whole idea, under Gabor Horváth, whose main field is the visual ecology of animals that navigate by polarization. His group took the hypothesis apart into steps and tested each step separately. First, they measured how much of the polarization signal is left in the sky over the Arctic, in fog and cloud. Then they put crystals into people's hands and measured how far off the readings came, for calcite against cordierite against tourmaline. A planetarium experiment on human subjects tested whether a person given the polarization at 2 patches of sky can then work out where the sun is. They went outdoors to check whether Heydinger's brush can be seen at all on a real sky in real weather. Every step worked, and every step carried an error that was passed along to the next one. In 2018, they put the whole chain together and ran it as a voyage. Their route was the historical crossing from Hernar, an island north of Bergen, west along about 60 degrees north to Hvarf on the southern tip of Greenland. They simulated 1,000 3-week voyages under randomized cloud conditions for each of the 3 candidate crystals at spring equinox and at summer solstice. And they varied the one parameter that turned out to matter more than any other, which was how often the navigator stopped and took a reading. Check every 1, 2, or 3 hours, and the ship reaches Greenland between about 92% and 100% of the time. Stretch the interval to 4 hours and arrival falls to somewhere between about 30 and 60%. Past that, the pattern stops being tidy. At 5 hours, the summer solstice voyages almost all fail, while the spring equinox voyages almost all succeed. Because of the way the checking times fall across the hours of daylight each season allows, and by 6 hours, almost everything fails whatever the season, whichever of the 3 crystals the navigator was holding. A follow-up in 2022 varied 6 things at once, among them the season, the crystal, the checking interval, and the weather. A sailing success was robust against cloudiness. It made almost no difference to the ship's arrival if the sky was mostly clouded rather than lightly clouded, or if the cloud sat steady rather than changing constantly. Night sailing made all the difference. At a 3-hour checking interval at summer solstice, a crew that stopped navigating at night arrived 19% of the time, and a crew that kept navigating through the night arrived every single time. Horváth has been careful in public about what this does and does not show. Their simulations assume calm water throughout, with no storms, wind, currents, or drift. Scandinavia's coast is thick with Viking ship finds, wrecks and burials both, excavated with enormous care over more than a century. And not one has produced a calcite, a cordierite, or a tourmaline crystal, or any other object anyone can identify as a navigational instrument. An attempt in 2014 to use Iceland spar on the water by a science journalist working with mineralogists from the British Geological Survey did not produce reliable results. A short paper in Applied Optics in 1994 by Kurt Roslund and Clees Beckman carried the title Disputing Viking Navigation by Polarized Skylight. Its abstract states that the widely held notion that the Vikings used skylight polarization on overcast days is demonstrated to have no scientific basis, and that its use under partly clear skies should be treated with caution and skepticism. Their argument was practical. A dichroic crystal darkens only weakly in diffuse light, and the change is hard to judge, while a sailor who wants to know where the sun is on a broken day can generally find it faster by watching which edge of which cloud is bright. Schnall had gone through the written sources for Viking navigation nearly 20 years earlier, in 1975, in a monograph for the German Maritime Museum, and concluded not merely that there was no evidence for a sunstone at sea, but that there was no clear need for one. Whether the Vikings could have used sunstones is one question. Whether they did is another, and it is the one historians are asking. One class of object keeps being offered to fill the archaeological gap. A Norse site on the Uunartoq fjord in southern Greenland, at a place associated with a Benedictine convent, gave up a broken piece of wood in 1948. About 7 centimeters across, with a hole in the middle and notches cut around its surviving edge. Carl Salver proposed in 1953 that it was a sun compass. Put a pin in the hole, trace the curve the shadow tip makes over a day, and thereafter you can recover your heading by matching the shadow to the curve. Replicas built on that reading have been tested at sea ever since. In a forum in the Journal of Navigation in 1954, one contributor counted 17 notches on the surviving fragment, a spacing that reconstructs to about 36 around a full circle rather than the 32 points of a mariner's compass rose, and another pointed out that the spacing is irregular anyway. Later microscopic examination found the incised curves on the face doubled and imprecise. Horvath's group has offered a further reading as a twilight board to be used with a sunstone after the sun has set. Others have read it as nothing of the kind. It has been identified as a confession disc, a tally a priest turned to keep count of parishioners who had confessed, of a type known from later Icelandic examples. In that same forum of 1954, one commentator proposed the lid of a small wooden keg, on the grounds that the workmanship is too rough for an instrument. 2 further wooden discs, from the Baltic trading towns of Wallen and Trousseau, have since been reassessed alongside it, and nobody has agreed on what any of the three was. The Icelandic scholar Árni Einarsson had already spent years arguing that Hroðulf's Þátr is a sustained cosmological allegory in praise of Saint Olaf, that the house in the dream is a model of creation, and that the story is not reporting anything. In 2010, he put the question directly in the Icelandic journal Gripla under a title that translates as "The Sunstone, Instrument or Symbol." His objection to the navigational reading is partly technical and partly literary. Technically, a polarizing mineral gives you the bearing of the sun and nothing else, and bearing alone is not much help in the middle of an ocean where the real problem is knowing your position. Literarily, both of the narrative sources are drenched in allegory, which makes them poor documents of practice. There is a further reading, drawn from a wider medieval tradition. In it, the sunstone is an image of the Virgin. Light passes through the stone, and the stone is not broken, exactly as the sunbeam passes through glass and leaves the glass whole. And that image of light through unbroken glass was the standard medieval figure for the virgin birth. It appears in hymns, in sermons, and in painted windows, across several centuries and several languages. Under that reading, the passage is describing a miracle with a mineral in it. Einarsson himself does not conclude that sunstones never existed. Inventories are administrative documents, and there is no reason to doubt them. His suggestion is that the stones were what their context says they were: objects owned by churches and monasteries in a country at high latitude where the sun spends months low and the length of the day swings wildly, and where knowing the hour matters because the hours of prayer are fixed. In his account, the stone locates a hidden sun for the sake of the prayer clock. Thorstein Vilhjálmsson, a historian of science, supplied the English translation of the Hroðulf's Þátr passage that gets quoted in almost every popular article about sunstones. And in the paper where that translation appears, his own verdict is that there is no clear-cut evidence for a solar stone having been used at sea. The Norse found Greenland repeatedly for 400 years with a technique that is well attested and needed no crystal. They sailed along a parallel, running east or west at a fixed latitude until land turned up where it should. Sailing directions preserved in the Icelandic Book of Settlements tell a navigator to leave from Hernar, north of Bergen, and hold due west for Hvarf on the Greenland coast. Pass north of Shetland so that it is only just visible in clear weather. Pass south of the Faroes so that the sea cuts the mountains halfway up, and pass far enough south of Iceland to have its birds and its whales. It is a route described entirely in terms of what should be visible on either hand. Everything else in the toolkit is observational and enormous. A navigator read the height of the noon sun and of the pole star, and watched for the pile of cloud that sits over an island long before the island itself appears, and for the glare of ice thrown up onto the underside of low cloud, and for the direction of the swell, which holds its bearing through days of shifting wind. Seabirds mark the distance from land, since the species that feed close inshore are not the species that range far out. A 13th-century Norwegian dialogue known as the King's Mirror devotes long passages to sea ice, to the behavior of some 20 kinds of whale, and to reading the light for latitude. There was a word for what happened when none of it worked. Hafilla means to lose all bearings at sea. A ship becalmed in fog drifts on a current nobody aboard can detect, and the word appears in the Icelandic sagas often enough to be an ordinary one. One trader, sailing for Greenland and blown off course for days in fog, sighted a wooded coast he did not recognize and turned away from it without landing. No saga records anybody aboard reaching for a stone. The Alderney ship carried iron, fittings, shot, and above all guns. A mass of iron near a magnetic compass pulls the needle off true by an amount that depends on where the metal sits and which way the ship is heading. On a warship of the 1590s, the instrument that was supposed to have solved navigation was giving false readings, and giving different false readings on every heading. A device that reads the sky instead is unaffected by iron. That is the argument Rapars and Laflock made for the Alderney crystal, and the argument comes with an object, a fine spot, a pair of dividers less than a metre away, and a specific problem the object would have solved. A technique that has spent nearly 60 years being called Viking has its only physical evidence in the age of the magnetic compass. The saga stone is still a farmhouse story. A king in a snowstorm testing whether a boy is telling the truth. A calcite crystal's behavior under a cloudy sky is settled physics. What the word Solarsteinn meant to the person who wrote it down is not settled, and no amount of work on the physics has produced evidence about the word.